Hi, I'm Andrew Connell, and I'm an MVP for Office Servers and Services. In this module, we're going to look at building add-ins for Microsoft Excel. In this first section, we're going to look at working with tables and charts. So we're going to look at first the anatomy of an add-in, we're going to look at tables, we're going to look at headers, and then we're going to look at filtering and sorting tables, as well as working with charts and options with charts. The Office 365 platform offers a number of canvases for developers to embed and extend customizations. Office add-ins are just one of those different canvases that we're going to cover in this slide and module today. Let's start by looking at the anatomy of an office.js add-in for Microsoft Excel. All Office add-ins must call office.initialize when a page first loads in the add-in. If we're using newer Office.js capabilities, it is important that you check if the client supports those different extensions. And you can check this using the requirements.isSetSupported operation. For Excel JavaScript APIs, you should get context using the excel.run operation. Using the context, you can then load any properties that you might want to work with. Calling context.sync will execute a batch of operations. And context.sync is going to return a promise that can be used to get results or a previous operation and or perform new operations. Now, it is a best practice to catch and handle errors that might occur when working with Excel APIs, just like any other application that you may work with. Now let's look at the Excel object hierarchy. Before manipulating an Excel workbook, it's important to understand its hierarchy and how that relates to objects that you're going to work with in Office.js. As we saw in the previous slide, Office.js provides context to an add-in via the function excel.run. That context contains a workbook property. A workbook contains worksheets, which contains a number of collections, including charts, tables, and pivot tables, and more. Office.js allows you to easily traverse and manipulate this hierarchy. Many objects within a worksheet can be accessed directly from the workbook object, including tables and pivot tables. Worksheets are aware of their siblings with abilities to get next and get previous. You can get the active worksheet using the workbook.worksheets.getActiveWorksheet and set the active worksheet using the worksheet.activate function. Office.js also offers a number of events that developers can hook into for various worksheet actions by the user including the onActivated, onDeleted, onSelected change methods, and more. Let's look at tables and headers. First, with a range. A range is going to represent a set of one or more contiguous cells, such as a cell, a row, a column, a block of cells, or anything else. You can get a range object with the Office.js using a worksheet and an address. So, for example, A1:D4. That represents a range from the top left to the bottom right cells. Now, if we look at a table is established based on a range of data. The tables.add function accepts a data range with a flag to indicate if the table has headers or not. Existing tables can be retrieved by name and ID or iterated through. After a table is added, headers and table rows can be added using 2D arrays. A table created with a header flag will use the first row in the data range for its headers. You can also set headers using the getHeaderRowRange property values with a 2D array. So let's look at some code samples in working with tables and headers. Here are some examples of working with ranges, worksheets, and tables. First, we're getting a range based on an address in the current worksheet. And again, the current worksheet is available through context.workbook.worksheets.getActiveWorksheet. Next, we're adding a table to the worksheet based on a range and naming it the expenses table. We can use this name to easily re-reference the table later as seen in the next code sample. Next, we're setting the header row for the table using a two-dimensional array. And then you can also freeze the header row using the freeze panes collection on the worksheet and calling freeze row. And continue with our code samples. In this snippets that you see, the first sample on the slide deletes the third row of the table. Notice that we reference row 3 by an index of 1 because it is a zero-based index collection. The next sample updates the values of the second row in a table. And finally, we can add a few rows to the back and front of a table. The rows.add function takes the row index where to insert a null or a -1 is going to mean to insert at the very end. Anywhere other than the end, and all the rows will shift down to accept the new row. Now let's talk about filtering and sorting. With filtering, we can use any column of a table can be filtered using office.js. You're going to filter a column by getting the column and using the apply values filter function on its filter property. You can also programmatically reapply filters and clear filters on a table using the table functions reapply filters and clear filters respectively. As far as sorting goes, table sorting can be applied by passing an array of sort fields to the table.sort.apply function. You can reapply and clear table sorts using the table sort reapply and table sort clear functions respectively. And this slide shows 3 different code samples for applying a filter, for reapplying the filter, and clearing it after editing the filter itself. Whereas this slide is going to demonstrate how to sort a table by one or more fields. In this case, I'm sorting by the second column in descending order and the third column in ascending order. Remember, these are 0 indexed arrays. You can also see how to reapply sort after edits are made and how to clear a sort. Let's talk about charts. Microsoft Excel has become a playground for data manipulation and visualization, so it's no surprise that the Excel JavaScript APIs allow developers to add and manipulate those charts. Charts exist within worksheets, but can also be accessed directly from the workbook object. Charts have a number of complex relational properties that can be used to fine-tune the look of a chart. These include titles, legends, axes, series labels, format, and many more things. Charts are created based on a data range and are often created in conjunction with tables. The worksheet.charts.add function is used to create a chart, which accepts a chart type, which is discussed more in just a moment, a data range, and a series by. Possible values include things like auto, scalar, and matrix. Now this slide has got a lot of information on it, and it's really going to be just a reference here. What it does is it's showing the script for adding a chart and then all the different supported chart types. You can think about just about every chart type imaginable is supported in this function. Now, as far as the different properties on charts, this table is going to outline the properties of a chart object in office.js. And notice a number of the properties to determine the appearance, such as height, width, and top, and many that are used to make the chart easily referenceable, such as ID and name. We also have one called Show All Field Buttons, which represents whether to display all the field buttons on a pivot chart. Now, relationships on the chart object can make a big difference in how the chart appears. Here we can see a list of a bunch of different relationship types and their descriptions to manipulate things like the axes, the labels, legends, series, title, and more things like the worksheet as well. So the code sample for looking at charts here, what we're going to see on this slide is this sample shows how to first insert a new chart and getting an existing chart based on a name. The new chart is being defined as a clustered column chart based on some table data. And I'm asking Excel to figure out if it should be charted either row-wise or column-wise by passing in the auto property parameter. Below, you can see how you can use office.js to manipulate the details to perfect your chart that you want to customize after it's been created. So it's kind of like a two-step process. In this demo, we're going to look at working with some rich content within a Microsoft Excel workbook using a Excel add-in. And specifically, we're going to look at working with tables and charts. So what I'm going to do first is that I've already got my add-in loaded, and I'm going to go ahead and launch it by clicking on the Show Task Pane button that I have in the add-in command. And you can see I've got a number of different samples that we're going to work with. So the first thing that I'm going to do is I'm going to create a table. And so I'm going to click on the Create Table button, and you're going to see that I've got a handful of columns and rows. That is a real table here that's got a nice header row and banded rows. So let's look at the code and see what made this happen. So here's my block of code for creating a table. I'm simply getting the active worksheets by going to context.workbook.worksheets.getActiveWorksheet. And I'm then going to add a table using a range. So I'm going to say A1 to D1. So I'm just grabbing the first 4 columns of the first row. And then I'm going to pass in true that this table will have headers. That's what the true value is. And I'll go ahead and assign it a name called expenses table. And that's going to allow me to make it easier for me to reference it later. Finally, I'm going to then add in the header rows. So I'm going to do that by calling the get header row range and pass into his values property. I'm going to pass in a 2-dimensional array. And this 2-dimensional array is going to have, it's just for one row. So the header values allow me to pass in a single array, a single item in that one 2-dimensional array that's got all my header values. And then after that, I'm going to add some rows to the table itself. So I'm going to go to the rows.add method, and I'm going to specify the location for where I want this data to be defined. Now, if I pass in a -1 or a null, it's going to add all the content to the end of the table. So in this case, it's a brand new table, so it's going to look like it's brand new data. But if I wanted to insert it into a specific row, I could use a 0-index array to specify where I wanted this to be displayed. And then the data I pass in is just a 2-dimensional array of rows. Now the next thing I want to show you is how to filter the table, but I want to do it programmatically. So I'm going to click on this filter table, and you can see that it filtered it down to just 3 rows in that category column. And it looks like it applied a filter called for category for education and groceries. So let's see how we did this. If I jump down to the code here, my filter table function, and first thing I'm doing is getting the current worksheet, and then I'm getting a reference to the expenses table. And see, I'm just going to tables.getItem and passing in the name of the table that we specified earlier and that I showed you in the earlier code sample. And the next thing I'm going to do is I'm going to get the column that I want to filter on from the columns collection on the table. And then I'm going to get the filter property of that column. And then to specify a filter, I'm going to go to the filter object and then call the apply values filter function, and then I'm going to pass in a collection of values that I want to filter on. So in this case here, I want to filter on education and groceries, and then I just sync my changes to the Excel workbook. Now let's see how to sort a table. So if I click on the sort table button here, and you can see here that it's sorted based on the merchant column. And if we take a look at the code that made this happen, if I go to sort table, you can see I'm getting a reference to my worksheet and my table, just like I did with the filters. And then I'm going to create an object here that is the sort fields that I want to define. So I'm going to call the sort property on the table and pass in to the apply function is an object that's got the fields that I want to sort on. So here I want to sort on one field that's the sort on the second column. So key of 1 means it's the 0 index to second column. And then I'm going to sort it in descending order. So I'm going to the ascending property and changing that to false to flip it around, to sort in a different order. If I want to sort in multiple columns, I could pass in additional objects into this array for the sort fields constant that I've defined here, and just using the sort property and apply method to apply those sorts. The next thing that I want to show you is how to create a chart based on the data in this chart. So I'm going to click on Create Chart. And that's going to insert a chart into my worksheet. So if I go over and look at the code for this, so if I go down to the code in my Create Chart, I'm getting a reference to my worksheet and my table that we've seen before. And then I need to get a date range, because the date range that I'm going to use to create the chart, the chart needs to know what kind of data it's going to show. So I need to convert the data in my table to a range. And so what I'm doing here is I'm going to the table and then I'm getting the data body range, which is going to ignore the headers, and it's just going to get the body of that table. Now I can define a chart. So I'm going to go to the worksheet itself. I'm going to say charts.add, and I'm going to pass in the type of chart, which in this case, office.js supports a lot of different charts, as we saw earlier in the slides. But in this case, I'm using a clustered column chart, or a column clustered chart. I'm passing in the data range that I want to display, and then I'm telling it to automatically determine how it's going to show the data. I'm going to let Excel figure that out for me. So should it be like row-wise or column-wise presentation of the data? From there, I'm going to set some additional properties on the document, like the position. So I'm specifying where I want it to show up from A15 down to F30. I'm then going to specify like the title of the chart, the legend of the chart, where it is, and how I want it to show up. I'm going to have the font size and colors of the different data labels that are going to be there, and even set different labels for the series here. So like I have this one as a value in euros. So this is just some of the stuff that you can do by customizing a chart. The chart object has got a lot of properties we can modify. Now the last thing I want to show you is how to freeze the header row on our table. But if you see, if I scroll, I'm losing my headers on my table. And what office.js allows me to do is to freeze a header. So if I click on freeze header here, you can notice that little line. Now if I scroll, you see my header for my table is never going to go away. So let me show you the code for this. So here you can see, again, I'm getting a reference to my worksheet, and then I'm going to call freeze panes.freeze rows and specify the row that I want to freeze. Another option that I could do is I could freeze columns if I wanted to. And so this is always going to be from the top of the worksheet. So in this case here, I'm only freezing the first row. That number that you see there, that's not a index, that's a count of the number of rows that I want to freeze from the top of the document. So this demo showed you how I could do a bunch of different things with my add-in inside of Excel, such as creating a table, filtering, sorting the table, and creating a chart and freezing the header. In summary, tables and charts are fundamental components of Microsoft Excel and are exposed through office.js for developers. Both tables and charts are defined using sample data ranges or 2D arrays. Now, office.js exposes a number of properties to fine-tune the look and feel of tables and charts inside of Excel. And just giving you some additional resources if you choose to read further, we see here we have links for the Excel add-ins overview and the Excel JavaScript API reference, as well as some samples, and then the documentation for tables and chart objects. In this first section, we're going to look at working with worksheets and add-in commands. We're going to look at basic worksheet operations, advanced worksheet operations, and add-in commands in this section. Worksheets and a workbook. A workbook is the root object when working with the Excel APIs. A workbook is a property on an Excel add-in context, and it contains a collection of worksheets. A worksheet, it contains collections for charts and tables and pivot tables and more. So a workbook is like the Excel file. A worksheet, those are the tabs that go across the bottom that you may be familiar with. Basic worksheet operations that you can do, we can interact with worksheets because that's a fundamental operation of building an Excel add-in. You can iterate worksheets off of the workbook object, or you can select specific worksheets based on name, ID, or being active or not. The worksheet being active or not. You can create worksheets using the workbook.worksheets.add function. Now, looking at the advanced operations, there's a number of advanced operations that we can do, such as binding to a worksheet events such as onActivated, onAdded, onDeleted, and onDeactivated. And you can also freeze worksheet panes and protect and unprotect worksheets. Now, here's some examples of working with worksheets. The first sample demonstrates how to get the active worksheet, and the second sample demonstrates how you can get a worksheet by its name. Next, the sample activates the worksheet, and then finally there's two more snippets here that are examples that demonstrate the creating and the deleting of a worksheet. Now here are a few more advanced but popular operations that you may want to do on a worksheet. The first sample uses the onDeactivated event to be notified when the worksheet is deactivated, and in this case, just logging some information. The second sample shows how to freeze panes in a worksheet. Now this sample freezes the top row, but you can also freeze the columns. And then finally, the last sample toggles the protection of a worksheet. Notice that you first must load the protection details before you actually change the protection status of being protected or unprotected. Now let's talk about add-in commands. Add-in commands can provide an easy way to customize the default Office user experience with specified UI elements that perform different actions. An add-in command is configured in the version overrides element of an add-in manifest. Add-in commands can extend existing content menus and ribbon and tab groups, or it can create an entirely new custom ribbon, tab, or group. Now we also have extension point elements. An extension point element defines where the add-in command should appear in the Office UI, including in the ribbon, both custom and existing tabs, and the context menus from right-clicking in the Office UI. An add-in command can support button and menu controls as well, where buttons perform a single action and menus provide a submenu of actions. As far as command actions go, the show task pane is the most common action for an add-in command. It's used to launch the add-in in a task pane and is part of most Office add-in templates and generators. The execute function is an action that allows an add-in to execute some script in the background without displaying any UI. And this type of a command requires a function file to be defined in the manifest that points to an HTML or a JavaScript file. Now, this chart here, this image that you're going to see here, is a bit of an eyesore, but I want to highlight how the manifest can be used to extend the Office UI ribbon. The primary part of the manifest is shown defined in the extension point on the primary command surface, which means the ribbon. With the extension point, the custom tab element is used, which means that the add-in will have its own custom tab to extend an existing tab. The Office tab element would be used. The custom tab has one group containing 3 root controls, 2 buttons, and a menu. And the menu contains 2 buttons of its own. Now I wanted to show an example using the execute function add-in command. And this type of command has 3 parts. You need a function file, which is an HTML page with a script block, and that script block must call office.initialize, and it should globally expose any functions that you want to call from a command button. You need to define that function file in the add-in manifest. You need a button with an action of type execute function with a function name pointing to the global function that you want to invoke. In this demo, we're going to look at how to do some more advanced operations on worksheets from an add-in inside of Microsoft Excel. And we're also going to explore add-in commands and how we can actually perform some add-in commands that may not even have a user interface. They just kind of run some code in the background. So for this, what I've done is I've set up a new add-in command called toggle worksheet protection. And I'm going to show you the function, and then I'm going to come back and actually run the demo so we can see it actually work. So let me first go through and close my task pane because I don't even need a user interface here. When I'm running this new add-in command, it's going to have nothing going on the UI. And you see when I click it, you'll see here it toggles the protection on the worksheet. So notice I can't edit anything inside the worksheet. So I toggled again, now it's all re-enabled. So it's protecting the worksheet from me making any changes to it as I'm viewing it now by clicking that button inside that piece. So let's see how this is pulled together. The first thing that I'm going to do is to define an add-in command. So the way I'm going to do is I'm going to define this using an XML manifest. So in the XML manifest, in here I've got a button. And this button is going to provide that functionality. So you can see here I've got this protection button. It's got a normal button there. And under the action, you see it's got a special type of action called execute function type. And what that's going to do is it's going to call a function called toggle protection that I've got listed somewhere. It's defined somewhere in JavaScript. So we're going to look at that in just a minute. But this button, so what this is saying here is that when I click this button, it's going to call this function toggle protection. Now, in order to set this up, one of the things I'm going to have to do is I'm going to have to create a function file. And so you see up here a little higher, I've defined a function file, which is just a simple HTML page that doesn't have any markup. It's just got the script in it to perform the code that I want to define or the capabilities I want to define. So let's look at that function file. So if I come over here, here's the function file. One of the things that you'll notice here with this is that I still need to define office.initialize. Again, this is important because any page that I'm going to load inside of an Office add-in, regardless if it's got a display to it or not, it needs to call office.initialize to let Office know that this thing is actually run. But here's the function that I was talking about. So here's the toggle protection function that's going to be called by our button. So that's really just how you pull together one of these add-in commands. Just need to create it inside one of these function files. Now, specifically for working on the toggling the protection piece, let's look and see how we can do that. So the first thing I'm doing is I'm getting the active worksheet that I'm currently on. So just context.workbook.worksheets and get active worksheet. And then what I need to do is I need to load the protection and protected information here before I actually work with it. So I'm calling sheet.load and passing in the value of protection and protected stuff. Now, whenever I do a load, I need to call sync because that's what's going to go do the round trip back to Office 365. So in the promise that's returned, then I can actually use those properties. So I've got sheet.protection.protected. If it's protected, then I'm unprotecting it. Otherwise, then I'm calling the protected method. So just toggling back and forth. And because I'm making changes, I need to do an additional context.sync that's happening at the end here. So this is just showing you how to run some code like in the background behind the scenes without having to define anything as part of the UI. I just want to have this run in the background using a function file to run this code when a add-in button is clicked. Now in summary, Excel JavaScript APIs offer a number of ways to interact with worksheets in an Excel workbook. Add-in commands are powerful ways to customize the default Office user interface with custom commands. The execute function commands can run script in the background without a UI. I want to leave you here with a couple different references that you can take a look at. There's an Office add-ins overview page as well as some details on the worksheet object, an add-in command sample, and how to create add-in commands. In this section, we're going to look at working with dialogs inside of Excel documents. We're going to look at a dialog overview, how to open dialogs, and then the dialog input and output, followed by a demo. The Dialog API and its extension of the user experience that you can customize inside of Office. You can use it to open dialogs from your add-in that interact with the user and your main add-in user experience. The primary scenario for this add-in Dialog API is authentication with third-party providers. Most identity providers are going to prevent their sign-in experiences from being displayed within an iframe due to clickjacking concerns. And this is challenging with an add-in because they're displayed in iframes in some of the clients, such as Office Online. Another challenge with authentication scenarios is predicting that the domains will be needing to load. In federated sign-in scenarios, the potential list of domains could be endless, which again is troublesome in an add-in where all the domains need to be registered in the manifest. So it's important to note that Office offers a single sign-on experience for specific Microsoft identities. So your add-in may require data about an Office user or their resources accessible through the Microsoft Graph, such as Office 365 or OneDrive. Microsoft recommends that you can use the single sign-on API whenever you can. And if you use the APIs for the single sign-on, then you'll not need the Dialog API. But beyond authentication, The Dialog API can provide additional screen real estate for elements that are difficult to display in a traditional task pane of an add-in. A really good example would be hosting a video that would be too small if confined to the task pane. As suggested when I mentioned the federated scenarios, the Dialog API can display any HTTPS web page, but you must launch it to an app domain first, and then you would redirect over to it. So here's a script that would be used to display a dialog from an Office add-in. And notice there are 3 parameters that it's requesting. The first is the URL of the page that you want displayed in the dialog. It must initially be a page that's hosted from an app domain as defined in the manifest. However, you can immediately redirect it to a different page. The options parameter allows the developer to modify the size of the dialog, and by default, the dialog will display as 80% of the height and width of the device screen. The values for the height and width are expressed that way, as a percentage of the device screen. And you can optionally set the display and iframe property in the options. Setting this to true will cause the dialog to display as a floating iframe rather than an independent window, in clients that support this, of course, which is going to make it open a little bit faster. The optional callback as the third parameter allows us to host a page that's going to respond to messages and events from the dialog. We're going to look at that more in just a minute. Let's talk about the dialog input and output. The primary way to pass information to a dialog is through local storage using the window.localStorage object, or through a URL parameter in the dialog URLs, like a query string value. In the sample you see here, the host page is passing an ID of 123 to the dialog via a URL parameter. A dialog can pass messages back to the host by calling office.context.ui.messageParent to send either a Boolean value or a string message, including a stringified object. To the host page, at the bottom of the sample, you can see the dialog script where it is passing the message hello from the dialog to the parent. The message parent function can only be called on a page with the same domain, including the protocol and port, as the host page. The host page must listen for messages by subscribing to the dialog.messageReceived handler. In this sample, the host page registers this handler using the process message function, where it simply logs the message. In this demo, we're going to look at working with the Dialog API from an add-in in Excel and Office.js. So I've already got my add-in loaded, so I'm going to go ahead and toggle the task pane up and again. This is from our first demo we ran earlier. And I got this button here called Open Dialog. Now, a dialog is going to give me a completely new user experience that I can deliver through my add-in. So as you can see here, my task pane is constrained over on the right-hand side of Excel. I can't do much resizing, but I can't do much changes to it. So for the most part, it's just kind of stuck in this one piece. If I want to deliver a bigger user experience for this, or I have certain authentication flows, as I talked about in the slides, I can implement the dialog. So if I click my dialog here, you can see where I can enter in my name into this. So I've got a bigger kind of experience here. So I'll click OK, and you can see that it brings back the information back to the task pane add-in. He can register a callback to get the response that comes back from the dialog. So the dialog actually was set up to message back to the parent. So let's look at how all this kind of comes together in the code. So here's my code for opening the dialog. So you can see I'm going to office.context.ui.display dialog async. And what I need to do is I need to pass in the URL to a page that I want to load inside that dialog. Now, I can use this to pass some information into the dialog, so I can pass in additional parameters such as URL parameters to it, or I can use like the local storage on the window object. Now, these the next thing I'm passing in is the dimensions of the dialog. So by default, it's going to be 80 and 80, and these numbers are percentages of the screen width that I currently have right now. So, you know, do I want, in this case here, the height is 45% and 55% of the current height and width of the screen. And then I'm passing in a callback. And what I'm doing here is I want to register some code to run when the pop-up kicks back some information back to me. So let's switch over and look at the pop-up and let's see how that's working. So Here's in the pop-up script, because our pop-up is part of an add-in, it needs to have Office initialize. Even though it's not a task pane or a function file, it still needs to call Office initialize. So what I'm doing then is that when someone clicks the button, I'm calling office.context.ui and I'm calling message parent and passing in a string. And what that's going to do is that's going to send back any Boolean or string value back to the caller. So I could pass in something more complex. So if I want to pass in like a JSON object, I'd want to pass that in as a string and then parse that out in the parent as a JSON object. So I can only talk back and forth from the pop-in to the add-in using strings and booleans. So here's where I'm processing the message, where I'm getting an argument that comes in, and the message property is the message that I actually passed into that function that we just saw a moment ago. And then I'm just going to show that on the screen here. So this shows you some of the basics of working with the dialog. There's a lot of scenarios you can use this for probably authentication is the biggest one. To where you'd want to go authenticate with, say, like Azure AD or with a third-party provider and get an access token and then hand that back to your task pane. In summary, the Dialog API provides a flexible extension to the add-in user experience. Dialogs can make and enable third-party authentication scenarios and scenarios where additional screen space is required by your add-in. Information can easily be passed to and from the Dialog API. In summary, I have a couple different resources here for you as well. We have the add-ins Excel overview link, as well as the API reference for the JavaScript API for Excel, which I've shown you at the end of the other sections as well. And then specifically for dialogs, I'm going to give you a link to a Dialog API sample that you can go grab, as well as the Dialog API for your Office add-in. That brings us to the end of our module. I hope you learned something about working with Excel add-ins in Office. Thank you very much.